Hi everyone and welcome. In the previous video we have covered that how we can control this Modbus IO card using Arduino Uno. Okay, so in that we have write a logic in the Arduino Uno that we are going to turn on and off this LED at every 1 second, and we are going to turn on this LED whenever our sensor value gets high or our sensor sense something. Okay, so the same thing we want to implement in the Python in this video. Okay, so we are going to write a Python script. In that script we are communicating with this Modbus IO card. Okay, and we are writing a logic in the Python, and based on that logic this device will work. Okay, so we are going to implement the same logic that we want to turn on and off this LED at rate of 1 second, and we want to turn on this red LED whenever our sensor sense something. So right now sensor is sensing this screwdriver. Okay, you can see the red LED on the sensor, but it is not acting. This Modbus IO card will not turn it on because we didn't run our Python code. Okay, and I have connected this Modbus IO card with this ATC converter. This is nothing but a serial to USB converter. Okay, and I have connected the second end of this converter to my PC. So this is what we are going to implement, and this Modbus IO card is brought to you by the Augmatic Technologies Private Limited. They are the manufacturer of this card. Okay, and this card is having a capability of 4 digital output, 4 digital input, and the 4 analog input. Okay, so this 2 LED is connected on the digital output. Okay, so this green LED is connected on the DO1. This red LED is connected on the DO4. So we are going to turn on and off the DO1 at rate of 1 second, and we are going to turn on, or we are going to set true value to DO4 whenever our sensor is sense some object. Okay, and our sensor is connected to this Modbus IO card on the DI1. So we have to monitor this DI1 value as well. Okay, so whenever DI1 value gets low, I want to turn on this LED, and whenever DI1 is high, I want to turn off this LED. Okay, because this is the inverted logic sensor, or you can say NPN sensor. So if there is no part present, then it will give me 12 volt, and if there is a part present on the sensor, it will give me 0 volt. Okay, so that is why I have to write a logic that whenever the DI1 is low, I want to turn on the red LED here, and whenever there is a voltage on the DI1, I don't want to turn on the red LED. So everything I have write in the Python, you can see here. And one more thing, this ATC converter is connected with my PC on the COM3 port. Okay, so that is why I have used COM3 as a serial port parameter. Okay, so let's see from the beginning. So I have used the minimal Modbus library. Okay, so if minimal Modbus is not installed in your system, then you can run this command pip install minimal Modbus. It will download and install minimal Modbus package in your system. I have already installed in my system, so you will see something like requirement is already satisfied. Okay, you can see here requirement already satisfied. So it is already installed in my system. Now we will import the minimal Modbus package and the time, and then after we are defining some serial port parameters which include the COM port on which our Modbus IO card is connected. So our Modbus IO card is connected with my laptop via this USB to serial converter on the COM3 port. Okay, and the baud rate of this Modbus IO card is 9600, the stop bit 1, data bits 8, or you can say byte size 8, and the parity none. Okay, so this is the serial port parameter. We have to run this cell. Then after we have to create a Modbus object. So instrument is equal to minimal Modbus dot instrument, and the port number. So port number is COM3 on which my ATC converter is connected to my system. Okay, and the slave address is 1. I have used slave address 1 because this device is having a slave address of 1. If your device is having a slave address of other than 1, then you have to replace this 1 by your slave address. Okay, then after I have to set serial communication parameter in this Modbus instrument object. Okay, so that is why I have to run this cell, and then after I have written 2 function to read the coil status and to write the coil status. Okay, so I have to sense the sensor value. Okay, I have to read the sensor values, that whenever my sensor gets high, I want to turn on this LED, and whenever my sensor gets low, I have to turn it off. Okay, so for that reason I need to read the coil status. Okay, so coil status for DI1 is the coil number 4. Okay, so I have to read it. Okay, and to turn on and off, to turn this thing on and off, I have to read for a feedback purpose. Okay, so that is why it is important function to read the coil status and to write the coil status. So whenever you want to turn on your LED, you have to write value on your coil values, okay, like true or false. And so that is why this function is required. Okay, and then after our main loop, so main loop will have a logic. Okay, so the first logic is we are going to read the status of all coils. Okay, so coil status 0 to 7, so we are going to read all coil status. Okay, then after we are going to write coil status to 0. Okay, we want to toggle this LED, red LED, okay, at every 1 second. So that is why I have written this line here. We are going to blink this green LED at rate of 1 second. And then after we are going to check that DI1 value is high or low. Okay, so whenever DI1 will low, I want to turn this red LED on, and whenever my DI1 is high, I want to turn off this LED. Okay, so that thing I have written here, and this is 1 second time sleep for this LED, to turn on and off this LED at rate of 1 second. Okay, so let me run this 2 cell here, and we will run our while loop. Okay, so you can see our green LED is blinking at the rate of 1 second. Okay, now if I sense some object on the sensor, you can see my red LED is on. Okay, so the logic is working properly. So whenever this sensor senses something, it will turn on the red LED, and whenever there is no part present on the sensor, it will turn off the red LED. Okay, so this is very cool. You can control any industrial Modbus application using Python language. Okay, it can be your Modbus serial application, or it can be Modbus TCP application. This is Modbus serial device, so I have to write, everything for Modbus serial communication. And if I have Modbus TCP device, then I have already created so many videos for Modbus TCP devices. Okay, so I hope this thing is clear, that how to control this Modbus IO card using Python, or how to control this Modbus IO card using Raspberry Pi. Okay, why Raspberry Pi? Because this is the Python code. Okay, you can copy this Python code and put in the Raspberry Pi, and you can connect your Raspberry Pi with this ATC converter, and this ATC converter will send the command to this Modbus IO card. Okay, so you can operate this Modbus IO card using your Raspberry Pi as well. So that is possible. So either you can directly run this Python programming in your laptop, in your PC, and you can operate this kind of Modbus IO device, or you can also use this Python programming in the Raspberry Pi directly, and connect your Raspberry Pi with this ATC converter, as you can see here, and you can directly operate this Modbus IO card. Okay, and I will provide this code link in the description of this video. You can go to our GitHub repository, and you can download this notebook directly from our GitHub repository. Okay, so this card is brought to you by the Augmatic Technologies Private Limited, and they are the manufacturer of this card. Okay, so if you want to buy this card, then you can visit their website. You can directly call there on their salesperson number. Okay, now if you have any question or any doubt or any concern, then you can ping me on WhatsApp, Telegram, Instagram, anywhere, and I'll happy to help, and I'll happy to answer your question. So we will meet you in the next video. And in the next video, we are going to control the other card, okay, which is our analog output card from Augmatic Technologies Private Limited, and we are going to control that card with Python programming. Okay, so we are going to control that card, and we will see the DC voltage in this DC voltmeter. Okay, so stay tuned for the future videos, and till then, take care, goodbye, and thank you.